Okay, now we go to the problem number 11. In the problem number 11, we have a problem where there is a segment AB. We are given the coordinates of A, we are given the coordinates of B. We are told that there are 3 points C, D, E which divide this segment AB in 4 equal parts. Now, they have not given us the points, they have not told us there are 3 points, they have only said that the segment AB has to be divided into 4 equal parts. How do we divide the segment in 4 equal parts? Obviously, we will need 3 points, right? Now, 4 equal parts means this is congruent to this, is congruent to this, is congruent to this, all 4 parts are equal, alright? That's the situation. We are given the coordinates of the end points A and B. So A and B is given to us, and we are supposed to find out the coordinates of the 3 points in between the segment, right? Now, one thing will strike you here that since the segments are equal, since it is dividing into 4 equal parts, therefore you will have midpoint theorem applicable here. You can solve this easily by midpoint theorem. You can also solve it by section formula, but that's going to be calculation wise, it may be a little tedious for you. However, with midpoint formula you can solve it very easily. How? Let's see. This circle here, this point D, will be the midpoint of AB. Can you see that? This is AB. D will act as a midpoint of AB. D will be exactly at the center of AB. Right? So, using the endpoints AB, you can use midpoint formula and get the coordinates of D. That is the step number 1. So, get the coordinates of D by midpoint formula. That is the step number 1. Step number 2, now if you have got D with you, then A and D will come the end point. C is going to be the midpoint of AD. Look at A, look at D. This is A, this is D. C is exactly at the center of AD. So C you can find out by midpoint formula again, considering points A and D, mind you. Which are the endpoints are very important. So the endpoints A and D are to be considered here. That is to be kept in mind. So, using midpoint formula you get C. Same logic you will apply on this side. You know D, you know B, midpoint formula you will get E, because E is at the center of DB. E is at the center of DB. So, apply midpoint formula considering point D and B, and you will get the coordinates of E. So, that is how you will approach this problem. Alright? Now, it's mere solution. Let us solve it. So statement number 1, we will say point D bisects segment AB. Therefore, by midpoint formula on segment AB we get, so you are applying midpoint formula on segment AB and you will get, you have x4 equals to x1 plus x2 upon 2 and y4 is equal to y1 plus y2 upon 2. Okay, very important to understand. Your A coordinates are x1, y1, so you have taken x1 plus x2 upon 2 here, because x1, y1 and x2, y2, A and B are x1, y1, x2, y2. So here you have x1 plus x2 upon 2, there you have y1 plus y upon 2. Point D coordinates are x4, y4. So x4 is going to be x1 plus x2 upon 2. Similarly, y4 is going to be y1 plus y2 upon 2. That you have to keep in mind. Therefore, now x4 is equal to, what is x1? Minus 14. What is x2? 6 upon 2. y4 equals to, what is y1? Minus 10 what is y2? Minus 2 upon 2. So therefore, what is x4? x4 is going to be, you have minus 8 here divided by 2, and for y4 you have got minus 12 upon 2. So therefore x4 is equal to minus 4, y4 is equal to minus 6. So what is d? So you have got the coordinates of d now, which is minus 4 comma minus 6. This is very important because based on this now you're going to get the other two. So now you have got d. Now once d is got, you will get c and you will get e. Without d, not possible to get c and e by midpoint formula, right? Okay, now how do we, then we go to now c. So we will say, now point C bisects segment AD. Therefore, by midpoint formula, on segment AD we get, so midpoint formula on segment AD now. So what will we get? We will have x3 equals to x1 plus x4 upon 2, and y3 is going to be y1 plus y4 upon 2. How did we get this formula? Midpoint is x3, y3. So x3 is going to be a and d coordinates. So a coordinates are x1, y1, so you have x1. D coordinates are x4, y4, so you have x4. Is that clear? It's very important to understand how did you get x3 is equal to x1 plus x4 upon 2. It is midpoint formula only. A coordinate is x1, x coordinate is x4, right? And the c x coordinate is x3. The midpoint which you want, that x coordinate is x3, right? So x3 is equal to x1 plus x4 upon 2, and y3 is equal to y1 plus y4 upon 2. Is that very clear? Now when you substitute, what do you get? Therefore, x3 equals to, what is x1? Minus 14. What is x4? x4 you will get from here, minus 4 upon 2. And y3 is equal to, what is y1? Minus 10. And what is y4? Minus 6 upon 2. Okay. Now what happens? So copy down this much and then I can rub it out and continue further. So this is what I have, and the point D which I got is minus 4 and minus 6, right? This is what I got, so I will write it as it is. Okay. Now I will substitute. I will start doing the problem further now. So x3 equals to minus 14 minus 4 gives me minus 18 upon 2. y4 is equal to minus 18 upon 2, sorry, minus 16 upon 2. So this gives you minus 18, that gives you minus 16 upon 2, and therefore you have x3 is equal to minus 9, y3 is equal to minus 8. And so you have got the coordinates of point C, which is minus 9 comma minus 8. This is your second finding. So you earlier got D as minus 4 comma minus 6. Now you got C as minus 9 comma minus 8. Now the same logic you will apply to DB. Okay? And what will you say? You will say also we know point E bisects segment DB. Therefore, by midpoint formula midpoint formula on segment DB we get. So what do we get? Now point E is going to be the midpoint. So who's the x coordinate of E? x5. x5 is equal to, now which are the endpoints for E? DB. So D and B. So x4 plus x6. Now B is what? B is x2. See, this is x2 y2. Alright, this was x1 y1. So let's not confuse. So x4 plus x2 upon 2, and y5 is going to be y4 plus y2 upon 2. And therefore, what is x5? What is x4 now? Minus 4. What is x2? 6 upon 2. y5 is going to be, what is y4? Minus 6 plus what is y2? Minus 2 upon 2. And therefore, x5 is 2 upon 2, which is 1. y5 is minus 8 upon 2, which is minus 4. Okay, now I'll drop this part. And therefore, you have x5 comma y5 is 1 comma minus 4, and so you got point E is equal to 1 comma minus 4. So these are the coordinates of point E. Alright. So you got D, you got C, you got E, and then you will write your final answer. What will you say? Points minus 4 comma minus 6, minus 9 comma minus 8, and 1 comma minus 4. Divide the segment. You will write it in ascending order. First the value of C, then D, and then E. That's how you will write. You will start from C and go to E. So you will say the points minus 9 comma minus 8, points minus 4 comma minus 6, and the point 1 comma minus 4. Divide segment AB in 4 congruent parts. That's going to be your final answer after E here. That's going to be the final answer. So you will be writing it in the statement form. Okay? Copy it down. Now here we are exercise 5.2, problem number 12. What all things are we given? We are given segment AB. In the segment AB there are points P, Q, R, S. 4 points which will divide this segment into 5 equal parts, 5 congruent parts. Right? So that's what we have written. Let point P, Q, R, S divide segment AB in 5 congruent parts. What does that mean? That means segment AP congruent to segment PQ, congruent to segment QR, congruent to segment RS, congruent to segment SP. Right? Now, let A be x1 comma y1, and the value we are given as 20 comma 10. Let B equal to x2 comma y2, and the value we are given 0 comma 20. Right? Value of P is x3 y3. Q is x4 y4, R is x5 y5, S is x6 y6. This is what we have assumed, right? As shown in the figure. Now, what is the strategy and how are we going to tackle this problem? Let's understand that. Here, you know that each part is congruent to each other. So, if I want to find out the ratio of AQ and QB, what is that ratio going to be? 2 parts, 3 parts. In AQ, how many parts do you have? 2 parts, right? AP and PQ. These 2 parts make AQ. So AQ is made up of 2 parts. QB is made up of 1, 2, 3 parts. So what is the ratio going to be between AQ and QB? So you will say solution. we know AP is to, AQ is to QB equals to 2 is to 3. 2 parts is to 3 parts. So the ratio is 2 is to 3. Now, with this you can use section formula, right? So therefore, by section formula, who's dividing? Q is dividing. So x4 is going to be, which are the points that it is dividing? AB. It is dividing segment AB, right? So you are applying section formula on, by section formula on segment AB. So you are applying the section formula on segment AB. So you are having x4 is equal to mx2 plus nx1 upon m plus n, and you will have x5 is equal to my2, you will have y4 is equal to my2 plus n by 1 upon m plus n. Therefore, x4. Now, we don't know x4. Do we know m? Yes. So, you will say, therefore here, let m is to n equals to 2 is to 3. Alright? So, we can assume m ka value as 2. What is x2? Where is x2? Here. x2 value is 0. What is x1? 20 upon 2 plus 3. Similarly, what is y4? The value of m is 2, y2 is 20, 2 into 20 plus 3 into y1, y1 is 10, y1 is 10 divided by 2 plus 3. So what do you get? You get therefore x4 is equal to 0 plus 60 upon 5, y4 is equal to 40 plus 30 upon 5, which is 70 upon 5. So you get x4 equals to 5 12s are 60, and here you will have 14s are, so here you have 14s are 70, so you will have x4 value as 12 and y4 value as 14. So what did you get? Now you got the value of coordinates of q. So q x4 y4, which you had assumed, you have now got it as 12 comma 14, right? So you have got one of the points. So one of the points you have got. So we can see this is got as 12 comma 14, we can mention it. Comma 14. Okay. Now this point P you can find out by midpoint formula, because this is falling exactly in between these two, correct? Right. Now how will you find out this and this? So again you will use section formula for any one. Let us say you can find out R by section formula. Okay. So, or you can, once you get P, see you have got A, B you had, and you got Q using section formula. Now using midpoint formula you will get P. Then again using midpoint formula you can get R, and then again using midpoint formula you can get S. So one section formula and all the rest midpoint formula, you will be able to get each and every point. Okay, so copy down till here and then we will go further. So now we rub this part and then we will start with finding the others. Okay, so how do we find now point P? As I said, now point P is going to be the midpoint between A and Q, right? So P is going to act like a midpoint of A and Q. So we will say point P bisects segment AQ. Therefore, by midpoint formula on segment AQ, we get, so what do we get? What do we get? The midpoint is x3 is equal to x1 plus x4 upon 2, and similarly y4 is equal to y1 plus y4 upon 2. Substitute, so you will get x3 is equal to 20 plus 12 upon 2, and this is y3 here, I'm sorry, this is y3. y3 is equal to y1 is 10 and y4 is 14 upon 2. Alright? So 20 plus 12 upon 2 and 10 plus 14 upon 2. So x3 is going to be 32 upon 2. What is that? 16. And here y3 is 24 upon 2. What is that? 12. So you got P. So therefore P is equal to x3 y3 is equal to 16 comma 12, and this is the second point you have got. Now with this second point, now your problem is simple. So once you use section formula to get Q, and now everywhere you're going to use midpoint formula and you're going to find. So with one midpoint formula you could find P. Now you select segment PR. Select segment PR. You know P, you know Q, only unknown is R. So apply midpoint theorem and get the value of R. Get the coordinates of R. Right? After you get R, then you select RB. Select RB and apply midpoint theorem to get S, because S is going to act like a midpoint to RB. So that's how you're going to solve the problem. So let's stop this part now. So we will write here, we have got x3, y3 as 16 comma 12. 16 comma 12. Okay. Now as I said, you will consider PR. Now, point Q bisects segment PR. So you're saying PR and you're saying Q is bisecting PR. So by midpoint formula, on segment PR, we get, so what do we get? We will say, who's the midpoint? Q. So x4 is equal to x3 plus x5 upon 2, and then y4 is equal to y3 plus y5 upon 2. Alright, now let's substitute. X4 we know 12, x3 we know 16, x5 is unknown upon 2. y4 we know as 14, y3 is 12, y5 is unknown, divided by 2. Therefore, Now take the 2 here. So you have 24 is equal to 16 plus x5, and here you have 28 is equal to 12 plus y5. What is x5? 24 minus 16 will give you x5. So x5 is going to be, what is 24 minus 16? You got 8. Same way here, 28 minus 12 is equal to y5, and then you get 16. So y5 is equal to 16, right? And with that, with x5, y5, you have got the coordinates of r. So therefore, r is equal to x5, y5 is equal to 8, 16. So you got the next point. So now you have got 3 points, 8, 16. So then I will now mention here, this is 8, 16. Alright? Now only 1 point remains. So for that 1 point, what will you do? Now you will select RB and apply midpoint theorem to get the coordinates of S. Okay? Let's do that. So I'll rub this part now. Okay, so now I will say you have got R, and then after that you will say also point S bisects segment AB, not segment AB, segment RB. You will say segment RB. We can see that S bisects segment RB. Therefore, by midpoint formula on segment RB, we get, what do we get? Let's apply. S6 is equal to x5 plus x2 upon 2. y6 is equal to y5 plus y2 upon 2. So, what is x6? We don't know. What is x5? 8. What is x2? 0 upon 2. What is y6? y5 is 16. y2 is 20 upon 2. So, what is x6? 4. What is y6? 36 upon 2, and that is 18. So finally, what's your answer? Therefore, S is equal to S6 Y6 is equal to 4, 18, and that gives you the fourth point rather. Okay, so you got the 4th point, and then you can say I got this as 4, 18. Alright? So you see how we solved the problem. We applied section formula to get Q, and then midpoint theorem we got P, and then midpoint theorem we got this, and then midpoint theorem between this we got this. Right? So it was all midpoint formula all the way except for one place where section formula was used. Okay? Great, so copy this, have a nice time. Bye bye.